Hello all, let's start your first lecture of statistics class. The first lecture in this video lecture, I'll cover section 1.1, 1.2, 1.3. But before even doing that, let me tell you in your book, always the first section is review and preview, correct? There is no lecture actually in 1.1, 2.1, 3.1. It's just they put the topics in this section. Your actual lecture starts from, in this chapter, from 1.2, or if we go to chapter 2, we will start with 2.2. 2.1 has nothing. You can check the presentations, you can check your book, that in section 1 of each chapter we have nothing to discuss, correct? It's just the topics of the section. This video will cover 1.2 and 1.3, and I'm talking about the key words that we are using in statistics. The first one, the important one, is data. What is a data? Correct? In our daily life, every day we are talking about data. Correct? We are collecting data. This is the time to know a very simple definition. What is data actually that every day we are talking about? A simple definition we call collection of observation. Data is a collection of observations. You observe something and you collect data. The good examples, if I put examples for you here, the good examples, measurement. Correct? For example, you're collecting data about gender. You do a survey. Correct? All of these can be example of the definition of data. Collecting or collection of observation, we call it data. Correct? The second important word is statistics, which is the name of your class. What is statistics? When you collect a data, then you analyze the data, then you summarize your data, then you interpret or translate your data, correct? And you draw conclusion out of it. And draw conclusion. From your data, correct? All of these steps, we call it together statistics. Collecting data, analyzing your data, summarizing it, translating on or interpreting your data, then out of that, drawing a conclusion, giving recommendations. This process in general, we call it statistics. This is the topic of study of this course. If you just collect data and you didn't analyze, you don't summarize, doesn't give any meaning to most of the people. For example, you're working in an office and you run to your boss office and you say, hey, I have a lot of data, I collect a lot of data. Your boss will look into you and say, okay, what should I do with this data? What is this data about? It means you didn't analyze it, correct? Many people, they don't know math. You have to use different language for them to explain your survey or explain why you collect this data. This process is the concern of your class, which we call it statistics, correct? Another important word that you see during the semester, all these words, believe me, that I put today as a note for you, and also there is a better, maybe better or longer definition and PowerPoint slides that you have in your Canvas. You use it every day until end of the semester. Then it's better to get good notes and learn them, correct? What they are. Population. Why I put a line here? With this electronic pen, it's really difficult to write, but I'm trying to write nicely for you. What is a population? The complete set of elements being studied. Good examples. When I'm talking about the students of MSGC, all the students of MSGC, I call them the population, correct? If I want to study this, for example, about how many of them they attend a statistics class, it's a study that I want to do on MSGC students, on all students, then I call the students of MSGC the population. Or your class, which consists of 40 students, correct? And my math 140, correct, which is a statistics class, I have 40 students in my class. If I want to do a survey which ages are in my class, correct, I call the students of my class, which is all 40 of them, the population in my class. You are very familiar with this word, the population of California. It means men, women, children, whoever lives in California. Population of United States of America. All of us that we are living in United States of America, correct? We call it the population. Now, usually in this topic, in the statistics, when you do a survey, when you do a study, it's so difficult. Sometimes it's impossible to do your study on a full population. For example, I want to see how many students actually likes mathematics in MSGC. If I want to do this survey or this study, if I want to target the population of MSGC, there's all the students, it's so difficult for me. How many students we have in MSGC? And I have to go ask this question from each one of them. Do you like mathematics? It's so difficult. Or if I want to kind of think about bigger picture, if I want to see how many people in California likes mathematics, how many people are living in California, and I have to go door to door and ask each one of them, it's so difficult. Then what we do usually in our class, we target a smaller population and we do our study on that smaller population, and based on that we can talk about the whole population. Then I'll put another important, very important word here for you, sample. Okay, usually you pick a sample from a population and you study that sample. It means you collect data from that sample, you analyze it, you summarize it, you interpret, and you draw a conclusion from that sample. Then in chapter 6, 7, 8, and those chapters, you will learn how you link this sample to the whole population. Correct? And you can talk about population. Correct? Now, what is a sample? Some subset of population. Correct? A subset of population, we call it a sample. We are not using the word subset in statistics, we use the word sample. You pick a sample. In biology and chemistry, you pick a sample. Correct? Next word, census. What is census? Collecting data from every member of population of a population. Census means collecting data from every member of population. In some countries, and I think also here in the United States, in our country, government do census every few years. They go door to door and they ask questions. How many men are living in this house? How many women are living in this house? How many children, correct? They collect this information and they call it census. Even we have a census office, correct, in the government. It means collecting information, or sometimes I say information, but it's better to use the word data. Collecting data from every member of a population, we call it census. Remember, when you talk about collecting data, you have to remember if, I'll put a star here, but later we will talk about this more. If you take a sample, it must be collected randomly. Correct? because I told you, usually you are not dealing with population. It's so difficult to collect data from the all members of population. What we do, we pick up a sample, but remember this part, I put a red underline, I'll underline it with red. It must be collected randomly. Of course, I'll talk about this topic later a lot, but let me explain again here. Think about your class, or think about a presidential poll, correct? If I want to do a presidential poll and collect information for next presidential election, for example, there are two candidates, Mr. X from Democrat Party or Mr. Y from Republican Party. If I just go and ask my friends around, pick up a sample of my friends, because it's really easy to contact my friends for me. Of course, you know, sometimes we pick our friends the way that we are. They are sharing kind of the same idea with us. We usually become friends with those kind of people. Do you think that if I say, oh, do you like Mr. X from Democratic Party or Mr. Y from Republican Party? Definitely, because all of them is Democrat, or maybe they're all of them is Republican. They'll say, oh, Mr. X is the best. He will win. He will win. He will win the election. And I'll publish my survey to the people that, hey, a group of the people, we did a survey and they say Mr. X will win the next presidential election. It's really dangerous to do that. Some people believe in this, right? No one wants to vote for a loser. Oh, everyone say, okay, I'll go and vote for Mr. X. But what we did here, the person who did this survey, we call him biased. This survey is a biased survey. Correct? You cannot pick a sample because it's this way is easy. Your sample should be or must be collected randomly. Correct? Later we talk about this a lot. Correct? It's just the first lecture. You should know just the definition and the keywords. Now, let's talk about types of data. Right? The first thing that I want to talk is parameter. What is a parameter? Parameter is a characteristic, the most longest word that I want to write, characteristic, correct? Parameter is a characteristic of population. In your book, they draw something like this. P is the first letter of parameter, and they put an arrow like this both ways. Parameter is linked to population. Remember this. Every time in the class, if I'm talking about parameter, it means I'm talking about population. Correct? Next one, statistics. Is a characteristic of a sample. Okay? Remember, when we talk about the statistics is a characteristic of a sample. It means they draw something like this in your book. S goes to S. Statistics deals always with sample. Parameter deals with population. Correct? You can call it here PP, P.P. Here you can call it SS. Parameter, population. Statistics, sample. Correct? Now, when you talk about data, there are two types of data. Correct? There are two types of data. First one, we call it qualitative data. What is qualitative data? The key word in qualitative is quality. Correct? It means the types of the data that you are just dealing with the quality, not with the number. Correct? Or in a better language, non-numeric, or even better than that, qualitative data is the type of the data that mathematical operation are meaningless. Let me put that definition first for you, then I'll explain it again, then I'll give you a few examples. Qualitative data are the types of data that mathematical operations are meaningless. I will explain why. You will see it. Are meaningless. Correct? Are meaningless. Correct? Examples. When you talk about color, when you collect data about color, green, yellow, red, blue, here with colors, you are talking about the quality. Mathematical operations are meaningless. For example, if you subtract from green red, it's meaningless. It's not giving you yellow, correct? It's meaningless. Or if you add red with blue, it gives you orange. No, it's meaningless, right? Adding, subtracting, multiplying, dividing. These are the mathematical operations, right? They are meaningless. We call those kind of data qualitative, correct? Or another example, gender. Correct? Male, female. Mathematical operations are meaningless here. Correct? Race. There are many examples. Religion. And I'll put this. Zip codes. Even zip codes, you see here number. Zip codes are numbers, right? But still, mathematical operations are meaningless here. For example, a zip code is 92532. Another zip code is 93569. If you subtract 92532 from, for example, 9569, it doesn't give you any meaning. It doesn't give you another zip code. It doesn't give you anything, correct? That's because it's just a zip code. correct? Mathematical operations are meaningless, even it's a number 92532, but mathematical operation is meaningless. Cell phone numbers, your phone numbers, correct? It's a qualitative data because the mathematical operations I'm doing, if you do multiply my cell phone number with your cell phone number, it doesn't give you your friend's cell phone number or someone else. It's meaningless, correct? These types of data, we call it qualitative data. Hopefully, because it's not a face-to-face class, it should be clear for you what is qualitative data. The second type, quantitative. Quantitative data. Or we can call it numerical data. Which type of data is quantitative data or numerical data? That mathematical operations are meaningful, correct? Type of data that mathematical operations are meaningful. For example, temperature. Correct? For example, height. For example, weight. Correct? Wages. And these types of data, or mile per hour, when you talk about mile per hour, correct? Here, mathematical operations, they are meaningful. How short you are than me, or how taller you are than me, correct? If you subtract, you can find the difference. Or temperature. If you subtract the day temperature from the night temperature, the difference shows how colder or how much the nighttime is colder than the daytime. Mathematical operations, they are meaningful. Correct? Or wages. How much I make per hour, how much you make per hour. If you subtract from each other, it gives you the difference. Who makes more, correct? Mathematical operations are meaningful. These are the two types of the data that I have to explain. We are done with section 1.1 and section 1.2. I'll stop the lecture. Even 1.3, all of them, I covered all for you, 1.2 and 1.3. The next lecture, in 1.4, I will talk about design of experiments and observation. What are the differences of observation and experiment? Correct? And of course, I'll put some more definitions there for you. Slowly we will end our lecture, our tiring lecture, which is chapter 1, and we move to chapter 2, which we do some math, also basics math, we learn some formula. But anyway, this was a lecture for section 1.1, 1.2, 1.3. I'll stop the lecture here and see you all in section 1.4.